Welcome to object-oriented programming. This is our first lesson, and my name is George Wainaina. I'll be taking you through this unit. So welcome, and I'll support you till the end. This is one of the challenging unit in Module 2, and we want to come up with a solution for that challenge so that when you'll be approaching the exam, you'll be ready for it. So to start, object-oriented programming is a high-level programming paradigm that is a programming approach that uses objects and classes. So saying that it's a high-level language, I want us to remember that there are two main categories of programming languages, high and low level. Low level, we have machine language and assembly. High level, we have procedural, non-procedural, and artificial intelligence. OP is a non-procedural language, this being fourth generation, 4GN. This mostly will concentrate on objects and classes. It will allow you as a programmer to organize softwares as a collection of objects, and this object will consist of data and behavior. Also, OOP, it will encourage modularization. This is whereby an application will be decomposed into modules, and also will have the idea of software use, where an application can be composed from existing and new modules. So in summary, object-oriented programming will have the main features: classes, objects, polymorphism, encapsulation, and inheritance. So let's start with a class. So when it comes to object-oriented programming, a class will provide a well-defined interface, and also it will have a clear concept, coming up with a complete and well-documented structure. And this class will consist of a complex structure within a programming language. The class will have state and a method. State in this case is a data, the data that are values that are associated with a given object, and the methods. Methods also are called behavior, which are the ways in which objects can interact with the data and the action. So in summary, note that OOP will always be mentioning objects and classes. For example, if we consider television as a class, in this case, we'll have state. State will be volume level, channel number, all that. The methods will include when you change the channel, when you change the volume, when you mute the volume, and all that. And also object, an object is an instance of a class. Whereas a class is a description of a concept, the object now will be the realization of this description to create an independent, distinguishable entity. So in this case, note that every class will be associated with objects. So these objects will be a concrete, or it can also be a conceptual representation of a database structure. Another keyword that we need to recall in OOP is encapsulation. Encapsulation will allow you as a programmer, when you're creating programs, to hide some concepts from the outside world, whereby the mechanism of the objects will be hidden, allowing the actual implementation of this object by hiding them, such that the outside world cannot interfere with your application. So note that encapsulation is a key concept in OOP, and this one provides a security mechanism. In object-oriented programming, we'll have three key terms when we start implementing classes. A class can either be private, public, or protected, and we'll use that to enhance encapsulation mechanism. Remember this, as a programmer, anytime you are creating an application, you as a user, you will understand the interface. Also, you as a user, you'll have to understand how the implementation is enhanced. And also, as a programmer, you don't need to notify the users the background functionalities of your application. So that is how encapsulation will be achieved. So Ed said we'll use three key terms: private, public, and protected. So public method also will be used to describe the interface. A private will be used to describe the implementation. Those are the key three terms we'll encounter as we continue. Then if we want to hide the internal implementation of application, we'll be using private keyword in object-oriented programming. Then another key term in OOP is inheritance. Inheritance means reusing of components. You may have a class that you have already defined, and another class, maybe assuming you have class 2. Class 2, you want to get properties from the first class that you had already defined in your application. You will not have to repeat everything that was there. You'll have just to call the class and you inherit the methods and the data associated with it. So as we proceed, we'll encounter different types of inheritance, including is-a relationship, part of relationship, kind of relationship, and has-a relationship. For example, we can say a car is a vehicle. So that's a form of is-a relationship. Anytime we are using a relationship in application, I want us to note these two key concepts. One, you can inherit a behavior and you add further specialized behavior. So in this case, a class that is already existing, you may inherit properties from it. Then your new class, you add more. So that is one form of inheritance. Another one, you can inherit a behavior and you replace it. You replace inheriting from an already existing class, then you replace with a new concept, such that you are trying to modify what is already there. So as we proceed, we'll have types of inheritance, including single inheritance, multiple inheritance, multi-level inheritance, and hybrid inheritance. And inheritance will be implemented that practically as we proceed. So you'll have to see that. Then another keyword you need to note in object-oriented programming is polymorphism. Polymorphism is the idea of having multiple forms of the same method within your application. You need to know this as a programmer. You can use the same method name, but these methods can be in different classes, or the same method but with different parameters. So in our case, polymorphism, we'll have runtime polymorphism and compile time polymorphism. Under compile time polymorphism, we'll have function overloading and operator overloading. And runtime polymorphism, I will implement that using overriding. In this case, we'll have virtual functions within our application. So let us differentiate the two key terms that I have mentioned, overriding and overloading. In OOP, those are the two key concepts that we need to understand when it comes to polymorphism. When you are overriding, you are allowing different kind of objects that share a common behavior to be used in code that will only require that common behavior. So in our case, we'll be using virtual functions. Virtual functions, implementing that using abstract classes and concrete classes. A class that will have the method to be inherited, we'll be calling it the abstract class. It will have the virtual function that will need to be implemented in class B that you're inheriting. That one now will become the concrete class. Then the idea of overloading will have the same name. The function will have the same name. So I want us to know this. When you're overloading, you can have the same function, but with different data types. For example, you can have a function called names. Then the parameters inside names, we have int x as one variable or one parameter or one argument. Then still within function or method names, we have float x. So the two data types, but the function is the same. So that one is one form of overloading. Another form is having the same method, the same function, but with a different number of parameters. We can have int names as a function, then argument int x, int y. From there, you can also have float nibs. Or let me just use the same data type, int nibs, but now in bracket, initially the first one had two parameters, int x and int y. But now this one, you may have one int nibs, but now in bracket, the argument will have int x. The first one had two, this one will have one. The moment you differentiate the number of arguments, that one you are overloading. So abstract classes, I've said that one will implement when it comes to overloading. So those are the key terms we'll encounter. Also abstraction, where we'll have to abstract some formalities of our application in object-oriented programming. So know this, why do we need object-oriented approach? When you're developing an application using an object-oriented mechanism, you will need to consider this. One, formulate the problem. You as a programmer understand the existing problem. Why do you want to create an application? To analyze that problem. You as a programmer, you need to find out the important concept of the problem. After you understand it, how am I supposed to solve this? Then design using different methodologies that are in place. That is phase number 3. You come up with a design that will map your solution. So it must be solution based on the analysis. Then finally, you code. But now for our case, we'll implement OP using C++ programming. So that's a brief introduction of the key steps. So also let us check waterfall methodology when it comes to software development. We need to follow these stages: requirement definition. You sit with your customer, understand the requirements they need, the software they want as a final product. You analyze. In this case, you use the software system models that are in place. You design, understand the input of your system that you want to come up with, the output and the processing involved within that application. Then you need to code, come up with a source code that will need a compiler later to translate to an object code to generate your application. Then you test your system. Once you are done with the coding, you'll have to test. You have to test and identify any bug within your application. A bug is an error. So if you're satisfied with your product, you'll install and convert. You can convert in that particular application where it will be used. That one is called, what we call beta testing. After you have tested in your development area, alpha testing, you'll have to test it within the locality of the intended recipient or those who will be using application. In that case, it will be beta testing. If you are installed and you are converted, you'll have to put it to operational. And later, as a software admin or a software developer, you'll have to maintain. As you maintain your software, you'll continue with adaptive maintenance, perfective maintenance, where you'll be adding new features to improve the performance of your software as you continue. So the object-oriented design model will have those key steps. So that is what we'll be using, or that is what we'll be doing in this application. For example, let me give you an example. If you consider a class called account being a class. So it will have these attributes: the owner, the balance in that account, the account number, the transactions logs, all that. Then let's consider another entity called deposit account. If we relate the two, deposit account and the main account, so deposit account is account. Now you see that kind of a relationship is a. And said we have 4 key terms we'll be associating with relationships: inheritance in OOP is a, has a, part of, and kind of. So deposit account is the account, part of the main account. Current account is a part of the main account. Oh, is a, not part of. Current account is a account. So those are the key concepts that we'll be discussing with you in this unit. Polymorphism, abstraction. So the concept of abstraction will focus on what an object does, what the object does, how it works. meaning it will manage large and complex programs. Encapsulation to hide unnecessary details from the user. Users will only see the application itself, the graphical user interface, without necessarily understanding how it is working on the background. Polymorphism, where you'll allow to define a method, the same method, but you can override by changing the argument or changing the parameters, or also you can override using the virtual function. Overloading, we have function overloading, operator overloading. Overriding, we have virtual functions. That one will implement practically as we proceed. Also, objects and classes are very key concepts when it comes to object-oriented programming. So that's a summary of this unit. So don't forget objects, classes, polymorphism, encapsulation, inheritance, and abstraction. Those are the six key words that I'll be using and I'll be referring several times as we continue in this unit together. So have a nice time, and in case you have any challenge, communicate to me directly and I will assist you. We'll meet tomorrow. We start with the next section of implementing objects and classes together. Thank you.